All right, guys, so I'm going to go over the notes again for those who missed it for literal equations. So we're going to do notes on solving literal equations. A literal equation is an equation that has more than one variable. And if you remember, variables just mean your letters, so like X, Y, Z. When we talk about literal equations, the most common type of literal equation that you will see is a formula. You may see these in things like physics class or even in geometry or other math classes. They help you solve sort of real-world situations. So we see some examples of literal equations over on the left, right? This one is one from algebra. This one is one from a physics class, right? So distance equals the rate times the time. The letters in this actually stand for things in real life, right? So distance is calculated by multiplying rate times time. Or the third one is from a geometry class, right? The area of a triangle is equal to 1/2 the base times the height, right? The b times the h. So if we were to give an example of a formula that we knew, this is something we did in class. A lot of you guys know the area of a square, right? So if I did area of a square is equal to the length times the width, right? L times W. So in solving literals, you are given values for some of the letters or the variables, but you need to solve for the other ones, the other variables. So to solve for this word, when you are asked to solve for something, right? For example, if I'm solving for x, what does it mean to solve for x? To solve for x would mean to get x by itself on one side of the equation and have no x's on the other side. This is a little different than when we solve a problem when you have only one variable, right, in a single variable. So for example, if I have something like 2x plus 4 equals 10, right, I can just very simply solve the numbers part of it and leave the x where it is, and I'm going to get dividing by 2, I'm going to get x equals 3. When I'm solving for a literal, it's going to look a little different because a lot of the parts of the equation are letters. So I can't necessarily solve for them unless I'm given a number to substitute for that variable. So we're going to look at some examples down below, and I think it'll make a little bit more sense as we go through it, okay? So for what variable are the following equations already solved for? Well, we see here that d is by itself, right? So the variable that's solved for is the one that's by itself. D equals r times t. So the variable that is solved for is d. In all these problems, it will tell you which variable they want you to solve for. When they say solve for, they're really saying like rewrite the equation so that r is by itself now. So we got to think about when it says solved for, don't really think about solving it as much in your way of thinking about solving, but more think about it as rewriting it for that variable. So currently it's solved for D. I want to solve for R. So one thing that I do that I think helps some students is I want to circle the letter that I'm solving for. You don't have to do this, but I think it helps to keep it in your mind that you are not going to move that letter. So essentially, you're saying, okay, the R is the one that I want to be by itself, so I need to get everything else away from it. So how would we solve the equation above for a new variable, the new variable being R here? Well, R is multiplied by T, so the opposite of multiplying is dividing. So I'm going to divide each side by T, just like I would if that were a number. If I had 2x, like I did here, right, I had 2x equals 6, I divided by 2. Right? Well, now I have RT equals D, so I'm going to divide by the T to make the T cancel. That leaves me with a new equation. D divided by T, which stands for distance divided by time, is equal to the R, or the rate. Now I have R solved for. R is by itself on one side. R is by itself here. I'm going to rewrite it with R on the left, but you can see that R is equal to D over T. Or rate is equal to distance over time, or divided by time. All right, let's look at another one. So A is equal to 1/2 B times H. which variable is solved for? Well, the solved for one is the one that's by itself. So A is currently solved for, but the question will ask you, now I want you to solve for H. I want you to rewrite it for H. So circle the H, and then I want to get rid of the 1/2 and the B on that side and move it over with the A. So I want to make sure that I can do the opposite operations of these two. Well, we know the opposite operation of a fraction is the reciprocal because we've practiced that. So we're going to multiply by the reciprocal of 2/1 on both sides. When I multiply 2/1 times A, remember though dividing by 1 doesn't really change anything. So 2 times A gives me 2A over 1. I'm not going to write the over 1 because I don't really need it. And then these on this side, the 1/2 and the 2/1 are going to cancel. So I'm left with a B times an H. So I got one more step. I still am not moving the H, right? I want the H to stay right where it is. But B is being multiplied by H. Just like if if 2 were multiplied by H, we would divide by 2. Now B is multiplied by H, so I'm going to divide by B. Divide by B. So the B's will cancel, and I'll get my next new equation, right? Equivalent, but written for a different variable. Now the B's have canceled, and I just have H. So I know that the height, right, or the H, is equal to 2 times the area, or the A, divided by the B, or the base. So height is equal to 2 times the area divided by the base. H equals 2A over B. All right, one more example here. All right, we got 3x plus 2y equals z. What is solved for? Well, again, the letter that is by itself is the z. So currently, my equation is solved for z. But I see in the instructions, it tells me now I should solve for x. So I want to get x by itself. I have an equation with 2 parts, 2 terms on the left side. I need to move this term and the 3 away from the x in order to get it by itself. How do I move a plus 2y? Well, it's a positive term, so I'm going to move it using the opposite, which is a negative term. When you write it over on the right side, try to write it a little bit further away from the z, and I'll show you why in just a second. When these ones cancel and I'm left with a 3x, I brought that down from here, right? I'm left with my 3x on the left side. I don't want to try to add these together because this is a z and this is a y. They are not like terms. So what I'm going to do is I'm just going to write z minus 2y on the right side. I've moved my 2y term to the other side and now it's a negative 2y. When I go to solve this part, I still just need to do a normal operation, opposite operation, which is divide by 3 on the left side. And if I'm going to divide by 3 on the right side, I can go ahead and just write it as one big divide. These cancel, and I'll write my new equation that x is equal to z minus 2y divided by 3. Hopefully you can see that. I know my camera might be a little bit in the way there. There we go. Okay, so I've given you some examples. I've also given you some practice problems to try out here, and there are some harder practice problems on the back for those who want a challenge. And if there are any questions, please just reach out and I will answer whatever comes. Hopefully you guys are seeing this isn't very different from solving a regular equation, just using letters instead of numbers.